To measure the speed of a rotating shaft, a tachometer sensor is often used. These tachometer sensors will measure pulses during the rotation of a shaft, and then the spacing between these pulses will be used to calculate speed. As the pulses are closer together, the rotation is measured as higher speed, whereas when the pulses are further apart in time, it'll be a decrease in speed. One such tachometer sensor is a magnetic tachometer sensor, and these can be used in conjunction with a gear. As the teeth rotate around, the proximity of the teeth to this magnetic tachometer sensor will create pulses. One type of issue that can be experienced sometimes using these magnetic tacho sensors is if you're using a gear with a missing tooth or missing teeth. Now, the reason that these gears are missing teeth is that these missing teeth are used to index positions when assembling parts, or maybe to index a rotational position to know what is going on in terms of rotation. When we use a gear with a missing tooth, we'll get a pulse train that looks like this, where we have equally spaced pulses except for where that missing tooth actually exists. So here you can see where the missing tooth is. There's a larger gap between these two pulses. And this larger gap, like we said, will correspond to a decrease in speed. But this decrease in speed is actually due to the missing pulse. It doesn't have anything to do with the performance of the shaft. But what we can do in TestLab to recalculate this pulse train with a missing tooth is go to Tools, Add-ins, and turn on Time Signal Calculator. And then once we turn that feature on, go to Time Data Selection, and we'll be able to perform some math on this pulse train to calculate the RPM. So first we'll load that raw RPM trace here, and you can see this is the same pulse train we looked at before in the Navigator tab. Then I'll go here to Formula, and I'll add in a formula called tacho pulses to RPM. Okay. And the function we want to do this equation on here is channel 3. So I'll type in channel 3. And for this particular gear, there's 36 teeth. And then our missing pulse correction, we'll scroll down to look at our available inputs for that. And so we have one missing pulse, so we'll put in 10 for that parameter. We'll say OK, and we'll calculate an RPM. When we calculate that, we can see we get an RPM trace based off this raw tacho pulse, but we actually see there's a large decrease in the RPM speed based on that missing pulse, even though we accounted for the missing pulse. If we look at this a little more closely, we can see how the pulse before and after the location of that missing tooth is affected. So first thing we'll notice is the slope of the line. So the positive slope here is affected by that missing tooth. So it counts the tooth before the missing tooth, and then the tooth after the missing tooth has an affected pulse here on the positive side of the slope. So if we copy this equation and paste it here and start making some changes, we can click Edit and go to the slope and change this from using the positive slope for the level cross detection to a negative slope. So we'll make that a 1. And going through some of these other parameters, we can look at the cross level. Right now that's set to 0, which is great for our particular pulse train, which oscillates from negative 0.15 volts to 0.15 volts. A couple other things we'll want to keep in mind are, going back to that missing pulse correction, we can see that the pulse before and after can be recalculated. And so we'll take advantage of that based on our discussion. And looking at this data, you can see that both the pulse before and after that missing pulse is affected. So we'll recalculate those as well. So we'll put in 13 here instead of 10. And we'll say OK. And now let's calculate this based on the changes that we've made in those parameters and see what we get. So now if I calculate that, let's overlay these two calculations and see if there's any improvement. You can see now where that missing pulse was, that based on the other parameters that we accounted for, that we get this nice correction here for where that missing tooth is. We no longer have this big dip in RPM speed that we had before. In this case, it was able to determine where that missing pulse was accurately and correct for the RPM that we were trying to calculate here, even with our missing tooth. So that's just some insight into how this calculation works. These calculations are also available online. To correct for a missing pulse during an acquisition, this can be done in the Siemens SimCenter Test Lab Signature Acquisition Workbook. Going to Channel Setup and making sure a TACO channel is turned on, the user can go to Tracking Setup, enter how many pulses per rev. Staying with our example, we could say there's 36 pulses per rev. Then, clicking on this More icon, we can see there's some additional parameters that we can take advantage of. For instance, how many pulses to skip. In our case, 1 pulse to skip. We can also change the mode to Advanced, do a missing pulse correction, the number of missing pulses we have, whether or not to skip any pulses that are neighboring, one before and after can be selected. And then we can also set the pulse correction factor similarly to what we did in the offline processing settings. This has been an example video on how to correct for a missing pulse. Thank you.